What if the very monsters of the cosmos, the black holes, were not endings, but beginnings? In the vast wilderness of the universe, there exist regions so absolute in their darkness that even the brilliance of stars cannot resist their pull. To wander near them is to risk erasure, to be stripped of identity, matter, even light itself. They are called black holes, and for centuries they have stood as symbols of cosmic finality, tombstones of dying stars, the ultimate graveyards. In an indifferent sky, yet, like all great mysteries, they refuse to be simple. The closer science peers into their depths, the more they betray another truth. What appears to be an ending may, in fact, be the seed of something unimaginable. At the heart of a black hole lies a paradox, a singularity, a point where the equations of physics falter, where density stretches beyond comprehension and time itself folds inward. Around it, the event horizon forms, the invisible frontier that nothing may cross back once it has passed within. It is both a wall and a doorway, a boundary that defines what is seen from what is lost. To gaze upon such a place is to confront a contradiction in human thought. How can there exist a region where the laws of reality collapse? And yet, they are not theoretical ghosts, they are real. Their shadows have been captured, their presence felt in the trembling of space-time itself. They are not imagined nightmares, but features of the cosmos as true as galaxies and suns. Imagine standing at a safe distance, watching as matter is devoured. A star wanders too close. Its gases stretch like molten taffy, spiraling into a glowing disk that blazes with more light than entire galaxies. This is accretion, the violence of feeding. In the process, black holes become paradoxical lanterns, their darkness framed by fire. Beacons of destruction visible across millions of light years. But beyond this spectacle lies the deeper question. Is this truly destruction, or is it transformation? The matter that vanishes does not cease to exist. It crosses a boundary into a realm forever hidden. Some theorists whisper that within lies not annihilation, but a doorway, a passage to another place, another time, perhaps even another universe. Here the imagination begins to wander. What if these silent giants are not cosmic executioners, but architects? Could the collapse of one world give rise to the birth of another? In the collapse of stars, galaxies are shaped. In their silence, space is sculpted. The very structure of the cosmos is laced with their influence. This duality, destroyer and creator, echoes in the human soul. For centuries, civilizations have written myths of gateways, of underworlds and heavens, accessible only through trial and terror. Black holes seem to embody these ancient archetypes, yet with the credibility of physics behind them. They are not myths carved in stone, but realities written in gravity. Even in death, black holes refuse to remain silent. Stephen Hawking revealed that they may not be eternal. They may whisper radiation, slowly evaporating across incomprehensible timescales. In their fading, they release secrets back into the cosmos, as though the universe itself is unwilling to let memory die. Every revelation deepens the enigma. To study a black hole is to glimpse the limits of human comprehension. They challenge not only astrophysics, but philosophy itself. What is time, if near them it stretches, slows, and fractures? What is space, if at their center it collapses into nothing? And what is reality, if such contradictions can coexist within the same universe? Consider the scale. At the center of our galaxy lies Sagittarius A*, a supermassive black hole 1,000,000 times the mass of the Sun. Around it, stars dance in tight, dizzying orbits, whipped around by an invisible force. Their ballet is proof of something monstrous concealed in silence. Without this heart of darkness, the Milky Way itself might not hold together. What we call home, our cosmic neighborhood, may be bound by a black hole's gravity. And so the paradox sharpens. The very entities we fear as devourers may be the very engines that allow galaxies, and therefore life, to exist. Death, it seems, is inseparable from creation. This is where imagination collides with science. The abyss does not only take hints at pathways we cannot yet follow. Could a traveler, falling beyond the horizon, emerge elsewhere? Could the implosion of a star open the womb of another universe, hidden beyond the veil of spacetime? Physicists wrestle with these questions, balancing equations that suggest impossibilities, wormholes, white holes, and baby universes. What is fantasy today may be the foundation of tomorrow's physics. To approach a black hole, even in thought, is to confront the edge of knowledge itself. Every answer births another question. Every revelation expands the frontier of mystery. They are more than astrophysical phenomena, they are metaphors for the unknown, symbols of humanity's eternal hunger to peer beyond the veil. For if the universe writes its secrets into the darkness, then perhaps it also leaves an invitation to imagine that endings are never final and that within silence lies the promise of new worlds. The abyss waits, silent but restless, its horizons shimmering like unseen doors. What first appeared as cosmic death now whispers of hidden beginnings. And so, the question lingers when theory met darkness. What did humanity truly discover? In the early 20th century, Albert Einstein unfurled his general theory of relativity, a tapestry of space and time woven together as one. Gravity was no longer a force cast from masses like invisible ropes, but the very bending of space-time itself. Stars curved the cosmic fabric, and planets moved not because they were pulled, but because they followed the warping of this hidden geometry. It was a revolution, elegant, profound, and terrifying. For buried in the equations was something Einstein himself never fully embraced: the possibility of collapse without limit. A pit where space-time curved so steeply it would break. Enter Karl Schwarzschild, a German physicist calculating from the front lines of World War I amid the mud and fire of trenches. He turned Einstein's newborn theory into its first exact solution. His mathematics revealed an object from which nothing, not even light, could escape. It was a perfect prison of gravity, a horizon beyond which time and space themselves could not return. This was no poetic flourish, it was written plainly, in the language of relativity, and yet, in those days, such objects seemed absurd. They were called singularities, mathematical monsters that surely could not exist in reality. Even Einstein dismissed them, uneasy with what his own equations had suggested. For decades, the idea slumbered at the fringes of science, a ghostly artifact of math rather than a prediction to be tested. The universe, it seemed, would not truly harbor such horrors. Stars might collapse, yes, but surely nature had a mechanism to prevent infinite descent. Surely the cosmos was not so cruel, and yet evidence began to whisper otherwise. In the 1930s, Subrahmanyan Chandrasekhar, a young Indian physicist traveling across oceans, calculated the fate of dying stars. If a star exhausted its nuclear fuel and its mass exceeded a certain threshold, no force, not even the pressure of electrons, could halt its collapse. It would plunge into darkness. Arthur Eddington, the great British astronomer, ridiculed him in public, unwilling to accept such morbid conclusions. But Chandrasekhar's mathematics held steady, a seed of truth waiting for time to grow. By mid-century, the whispers grew louder. Astronomers observed strange stars flickering X-rays, blasting from the heavens with unusual violence. These signals hinted at invisible companions, dark, compact objects feeding on nearby matter. Could they be the collapsed remnants of stars? The absurd was shifting into the possible then. In the 1960s, the phrase black hole was born, coined by physicist John Wheeler. Suddenly, the nameless monster had an identity. With a name came focus, and with focus came the hunt. One by one, candidates emerged. Cygnus X1, a stellar corpse pulling matter from a companion star. Quasars blazing with the light of galaxies, powered not by starlight, but by supermassive black holes at their cores. The universe was littered with them, not rare curiosities, but engines of cosmic structure. Meanwhile, theory grew darker, stranger. Roger Penrose and Stephen Hawking revealed that singularities were not mathematical quirks, but inevitable outcomes of relativity under collapse. A star of sufficient mass had no escape from its fate. Space-time itself would be dragged into an abyss. Hawking, restless and sharp, carried the paradox further. If black holes could swallow everything, what became of information? Was the universe itself erasing its own memory? His answer shook the scientific world. Black holes, he argued, were not entirely black. They would emit faint radiation, slowly evaporating across unimaginable ages. They could die. The cosmos' darkest objects were not eternal after all, but mortal still. Questions deepened. If they could fade, where did the information they consumed go? Could the laws of physics allow such loss? Or was there a hidden mechanism, a secret woven into the horizon? The mystery was no longer just in the mathematics. Observations were catching up. Telescopes tuned to invisible wavelengths captured X-ray bursts, radio flares, gravitational echoes. Then, in 2015, a century after Einstein's equations were born, the Laser Interferometer Gravitational Wave Observatory, LIGO, heard the tremor of two black holes colliding. The signal lasted less than a second, yet it carried the weight of billions of suns merging into one. For the first time, humanity had heard the sound of space-time ringing. The discovery confirmed not only that black holes existed, but that they moved, danced, and merged across the universe, reshaping the fabric of reality as they did. The monsters were real. The fantasy had become fact, and in 2019, the Event Horizon Telescope captured the first image of a black hole's shadow, a ring of fire circling the darkness at the heart of galaxy M87. It was proof carved into light itself, a silhouette of the unseeable. The photograph was not only an image of science, it was a portrait of imagination vindicated. From the trenches of war to the silence of observatories, the path of discovery revealed a pattern. Each dismissal, each doubt, gave way to truth stranger than fiction. What began as mathematical ghosts had emerged as cosmic titans shaping galaxies. And still, their essence eludes us. Do they truly annihilate what they consume, or do they seed new realities within their depths? Are they tombs, or are they doors? The story of black holes is not just the triumph of equations and telescopes. It is the story of human curiosity, refusing to yield, of minds daring to follow whispers into darkness. Where most saw absurdity, a few glimpsed possibility. Where many saw an end, some wondered if it might be a beginning. Now, the stage is set. The black hole is no longer fantasy, no longer doubt. It is real, it is near, and it shapes the heavens themselves. But the deeper mystery remains. What lies inside these horizons, and could they open paths to new worlds? The black hole has been unmasked, no longer a mathematical ghost, but a real presence stitched into the cosmos. Yet what it means remains unsettled. To fall into its horizon is to step into a question, not a conclusion. Scientists, philosophers, and dreamers have long wondered, what if the darkness conceals not just annihilation, but passage? 5 possibilities rise from this abyss. Each is a bridge of speculation, fragile yet luminous, carrying us toward worlds beyond imagination. 1. Wormholes, tunnels through space-time. First, the most famous of all, the wormhole, born from Einstein's equations and later shaped by the ideas of Nathan Rosen. Wormholes appear in mathematics as shortcuts through space-time, a folded page where two distant points touch. If black holes carve pits into the cosmic fabric, then perhaps those pits can connect, tunneling from one horizon to another. The idea is seductive, a voyage across galaxies in the blink of an eye. Yet nature resists. Wormholes, if they exist, are unstable, prone to collapse before anything could pass through. They would require exotic matter, substances with negative energy, to hold them open. For now, this matter exists only in speculation. Still, the allure endures. Physicists explore models where quantum fields might stabilize the passage, while storytellers imagine civilizations using black holes as gateways. The wormhole remains a symbol of hope, that the abyss is not only a prison, but a passage. 2. White holes, explosions in reversive black holes swallow. Then, what if the universe contains their opposites, objects that spew matter endlessly, never to consume? These are white holes, theoretical twins that reject everything, permitting no entry but constant outpouring. Mathematically, they emerge as time-reversed black holes, solutions buried in Einstein's equations. Some theories suggest that when a black hole dies, evaporating through Hawking radiation, it could rebound as a white hole, releasing the information once thought lost. Though no white hole has ever been observed, the concept lingers like an echo of balance. If the cosmos has graves, perhaps it must also have fountains. If collapse is real, so too might be reversal. 3. Star forges, creators of galaxies. Not all pathways lead beyond the universe. Some are already here, in plain sight. Black holes, especially the supermassive giants at galactic centers, are not only destroyers, they are architects. Their gravity organizes the motion of billions of stars, while their furious feeding ignites quasars that blaze brighter than entire galaxies. In this violence lies creation. Outflows of energy, jets of radiation, and tidal forces seed galaxies with the raw materials for new suns. Without black holes, galaxies might not cohere. Without galaxies, stars and planets might not form. Without planets, life itself would have no cradle. Here, the black hole is not a doorway elsewhere, but the engine of here, the forge in which the cosmos crafts itself. To call it destruction is to miss the deeper truth. Every end feeds a beginning point. 4. Exotic matter labs, cradles of new physics. The event horizon is a borderland where known laws falter. Gravity crushes, time distorts, and matter is squeezed into unknown states. Some physicists suspect that within this crucible, the universe may reveal secrets unattainable elsewhere. Could the core of a black hole harbor exotic particles, or even unify gravity with quantum mechanics? Could dark matter, still elusive, find its origins in such extremes? Some imagine black holes as cosmic laboratories, testing grounds where physics itself is rewritten. Humanity cannot yet enter these laboratories, but through mathematics and observation, glimpses appear. The dance of matter near horizons, the ripples of gravitational waves, the faint breath of Hawking radiation, each is a clue. Black holes might be more than objects. They might be keys, forcing us to expand the laws of reality itself. Point 5. Simulated universes, the cosmic incubator. Then comes the boldest speculation of all, that black holes may not only shape our universe, but give birth to others. Theorist Lee Smolin proposed the idea of cosmological natural selection, that each black hole could spawn a new universe beyond its singularity. In this view, our cosmos is part of a grand lineage, each universe budding from another's. Collapse. Inside these daughter universes, the constants of physics might shift slightly, favoring the birth of black holes in turn. A cosmic evolutionary cycle emerges. Universes that create more black holes proliferate, like species well adapted to survive. If so, our universe may itself be the child of another, birthed through a black hole in a parent cosmos now beyond reach. What we call the abyss could be the womb of infinity. Each collapse, a genesis. 5 pathways, tunnels, fountains, forges, laboratories, incubators. Each is unproven, fragile, speculative, yet each whispers a possibility, reminding us that black holes resist the simplicity of doom. They are thresholds, enigmas carved in gravity. The truth may be stranger still. Perhaps none of these paths are real. Perhaps all of them are. The abyss guards its secrets, but in its silence, imagination blooms. And so, at the edge of the event horizon, questions multiply like stars. Are black holes the universe's way of erasing, or its way of creating? The reflections grow darker, deeper, leading us to the final meditation. What do these mysteries mean for us, standing in the thin light of our fragile world? At the end of all journeys comes silence, the rush of discovery, the clamor of theories, the tremors of gravitational waves, all fall away until only stillness remains. In that stillness lies the image of the black hole, a circle of nothing, rimmed by fire, suspended in the deep. It is both presence and absence, both known and unknowable. Humanity has named it, measured its mass, captured its shadow. Yet what it is remains an enigma. The deeper science peers, the more it resembles a riddle written in the handwriting of the cosmos itself. If black holes are gateways, then the universe may be far wider than we imagine. Perhaps every horizon conceals an uncharted shore, collapse a passage. To fall into one might not be to end, but to begin again, elsewhere, else when such possibilities hang like faint lanterns in the dark, glimpsed through mathematics, but never yet touched. Still, there is humility in admitting the limits of knowledge. No telescope, no equation, no experiment has pierced the veil of the event horizon. The singularity remains hidden, cloaked by the very fabric it bends. Our instruments trace only the edges, the shadows, the trembling echoes in space-time. Beyond that frontier, speculation reigns. And yet, even speculation has power. It reminds us that the cosmos is not finished. It is still a mystery in motion. For centuries, black holes were dismissed as fantasies, the absurd offspring of mathematics. Now, they are pillars of astrophysics, shaping galaxies, forging stars, orchestrating the architecture of the heavens. What was once absurd has become essential. This is the lesson they leave us with. Never mistake mystery for impossibility. At the human scale, the paradox deepens. These are the darkest objects in the cosmos, and yet they give us light. They ignite quasars that shine across billions of light years. They hurl jets of matter into intergalactic space, seeding it with the raw ingredients of creation. They sculpt galaxies, and galaxies cradle stars, and stars give birth to life. In the end, our own existence may depend on the balance struck by these cosmic engines, and so the question lingers: are they destroyers, or are they creators? Or are they both woven together so tightly that the distinction no longer matters? Perhaps the answer lies not in physics, but in perspective. To a star consumed, the black hole is an executioner. To a galaxy held together, it is an anchor. To a physicist, it is a puzzle. To a philosopher, it is a metaphor. To humanity, it is a mirror of our own paradox, fragile beings staring into an infinite unknown. Wondering if endings are truly endings, there is poetry in their silence. Unlike stars, they do not burn. Unlike planets, they do not shine. They announce themselves not by what they are, but by what they hide. In their invisibility, they remind us that truth is often veiled, that the universe is not obliged to reveal its secrets simply because we ask, and yet we keep asking. We build detectors sensitive enough to hear the trembling of space-time itself. We assemble telescopes the size of Earth to capture a shadow cast across 50 million light years. We write equations that attempt to reconcile gravity with quantum uncertainty, chasing unity where none yet exists. This pursuit is not only scientific, it is profoundly human. It is curiosity refusing to be silenced even in the face of the abyss. What then do black holes teach us? That the universe is stranger than we can imagine, and yet more intimate than we expect. That destruction and creation are not opposites, but partners. That silence can be eloquent, and that even the darkest places may conceal hidden beginnings. In their paradox, we find reflection. Humanity, too, is bound by horizons, the limits of knowledge, the brevity of life, the finitude of perspective. Yet across every horizon we approach, there lies another, inviting us onward. Perhaps black holes are not only cosmic mysteries, but symbols of our own journey, reminders that to reach beyond is to risk, but also to grow. One day, perhaps, their secrets will yield. Perhaps quantum gravity will reveal the truth of singularities. Perhaps exotic matter will unlock wormholes. Perhaps a dying black hole will one day flare as a white hole, scattering its hoarded memory back into the cosmos. Or perhaps their silence will endure forever, a mystery the universe keeps to itself. Until then, we remain at the shoreline, gazing outward. The black hole looms not as an end, but as a question vast enough to anchor galaxies, yet intimate enough to stir wonder in the human heart. The curtain of the cosmos drifts closed, leaving us with only this: are black holes the universe's way of dreaming beyond itself?